Today we're going to use a little bit of the science behind motion and forces to teach you about a lesson of how to not give up, but also how to use a different amount of force to get a different result. So I've set up a Hot Wheel track here, just going over a little box. And this is something that you can do at home, even if you don't have the Hot Wheel track. If you have a toy car or anything with wheels that you can push or pull, you can set up different kinds of ramps using books, even tilting tables to the side. There's lots of ways to experiment with motion and forces, and you don't need anything particular. Well, first of all, let's go over some vocabulary. So we're going to be using some science words today. Motion is meaning that something is moving. That means that something is not at rest. Isaac Newton taught us about the laws of motion, and one of those was an object at rest will stay at rest, and an object in motion will remain in motion unless it's acted upon by an unbalanced force. So in kindergarten, we do a lot of just experimenting with what motion is, how to make things move, how to make things not move. And today we're going to be learning about how to make things move. The second vocabulary word I want you to think about today is force. Now, a force is something that acts upon an object. So it could be a visible force like a push. If I push this car, we know it's going to move. The opposite of that is a pull the car. The difference between those two is a push usually goes away from you and a pull usually comes to you. Now, lots of things cause pushes and pulls beyond just humans. If you're in bumper cars and one car bumps another, that could push it forward. If you are on a ski lift, you're being pulled up. The chair is being pulled up by a pulley, which is actually a simple machine. Cars, jets, all sorts of machines use motion and forces as well. Today, we're also going to be learning about acceleration. Now, acceleration is a change in either speed or direction. So if something is going along and we speed it up, that's an acceleration. But also, the friction of this carpet is causing an acceleration. It's actually slowing the car down. So a change in speed can be either an increase or a decrease. And then the third type of acceleration is a change in direction. So if I were to crash into this, which I hope you're all safe drivers out there, let's not crash on purpose, but just for pretend, if I go forward with a push and I hit the box, now we notice that I changed direction. Now the Jeep went backwards. So acceleration can happen from a speed up, a slow down, or a change of direction. One thing Kendrick was known for was never giving up. He was a problem solver. He competitively competed in robotics. He also really loved engineering. And part of being a good engineer is understanding a problem and not giving up until you've solved that problem. So today our problem is trying to get the Jeep over the box and to the other side of the ramp. So we're going to try with just a really soft push to start out, and let's see what happens. So we saw the Jeep start to go, but did we apply enough force to the Jeep to get it to go up the hill? Not yet. Okay, so the next time I want you to try it with a little bit more force. And this time I want you to try to get it to go almost to the top and then come back. So it takes a little practice. Let me see if I got it. Okay, so that time the Jeep went about halfway up the ramp and came back. Let's try it one more time. So that time I used just enough force to push it forward, but then cause a change of direction where it came back down the ramp and towards me again. So this time I'm going to use the most force I've used yet, and hopefully we'll be able to get it over the ramp. Yay! So experiments like this can be fun at home. you don't need a whole bunch of science equipment. You can use the toys you have around the house. What I always recommend for my scientists to do is draw a picture of the problem and how they solve the problem. It might have been changing the height of the ramp. It could have been applying more force. And there's always more than one solution to a problem. So I could have changed the ramp, or I could have applied more force. In this case, I applied more force. So draw a picture about what you did, and I can't wait to see. Hi everybody, it's Mrs. Thatcher with another kindness challenge. Today we're going to be talking about what we do when there's a problem. Now, part of spreading kindness is helping to solve problems. And when there is a real problem in your life, it's usually worth spending the time to look for a good solution and finding a way that you can solve the problem. That's what makes us a good friend. It's what makes us good teammates. It's what makes us good family members, sticking through with something and figuring out a way to solve the problem. It helps make our families stronger. It helps make our classroom communities more efficient. It also helps friendships to grow. I know that many of my problems have been solved with the help of other people, particularly family members and friends who took the time to find a good solution. So today we're going to be talking about finding a solution to a problem in science. In our last video, we did a little science with motion and forces, and we were trying to find a good solution to the problem we were faced with. The problem was that we couldn't get the Jeep all the way over the ramp, and so we had to come up with some solutions. So I'm going to model the writing part of this. The worksheet that comes along with it has the same format. I'm just going to draw it out on paper so you guys can see what it looks like at home. I don't have a printer at home, so we're trying to make do with what we have. So bear with me. So this here's my paper. On the top, I'm just going to draw a big box. That's going to be the problem. And then down here, I'm going to draw 3 boxes. Not very straight. And these boxes are going to be where I think of possible solutions. So, like I said, if you don't have a printer, it's okay. You can just draw it out at home and try your best. So our challenge today, we had to try and get the Jeep over at a box with a marble roller coaster in it, which is also a fun challenge. So here's our marble roller coaster box. And then over the box was a Hot Wheel ramp that we had kind of built to go up and over the ramp. And here's the connecting pieces of my Hot Wheel track. It's always good to add some details. Now, our problem was when I would send the Jeep up and over, I would give it a push and it would start to go up the hill right about to this point, and then the Jeep would accelerate. And by acceleration, I mean it would change direction or change speed. And in this case, it did both. It started to slow down and then it changed direction and went back down the ramp. So here's our Jeep. I'm pushing it up the hill, and then when it gets to this point, it's rolling back down. So 3 possible solutions is our next step. We know that the problem involves a Jeep. It's not like someone said unkind words to me or somebody broke my toy. This is a science problem, but using the same method of thinking helps us to solve our personal problems and our science and engineering problems as well. So let's look at the first solution. Could be the box that I used, the marble roller coaster box, was a little big. So I could take that bigger box and maybe make it a smaller box. So I could make the smaller box, that could be a solution. And then when my ramp went over, it wouldn't have to go so high, and I could push with the same amount of force and the Jeep could get over the box. Okay, solution 2. Possible solution could be that, I know sometimes when we're doing robotics in class, some of our robots can push and pull other objects. And so I could draw like a dash robot over here, and the dash robot could actually maybe tow the Jeep. So if I have a Jeep right here, I could attach a way for the Jeep to get towed across by the dash robot. So that could be one of my second solutions. This dash robot could pull or tow. So I'm just thinking I should probably write these down too. So here I'm going to say smaller box. Help me spell box, guys. B-ox, box. I heard 3 sounds, so I'm going to make 3 dots here. That way it reminds me I need 1 letter for each sound. Box, b-ox, box. All right, the next one is pull or tow. What's the first sound we hear in pull? That's right, P. And then it's a U and 2 L's, pull or tow. So that could be my second solution. Okay, the third solution involves something that I would do. So instead of just pushing it gently, like I kind of was, I'm going to draw a smaller arrow. When we draw forces, we usually try to make the arrow indicate the amount of force that the object is having exerted on it. So here's the amount I was using. I'm going to draw a much bigger arrow now. And this arrow is going to represent me using more force. You can tell that the direction is still the same. I'm just going to have a change in the amount of force. So I'll write that one up here. More force. Okay, so those are my 3 solutions and that I came up with. I could come up with many more. These are just the first 3 that I came up with. When I looked at my solutions, the one I chose that I thought would be the easiest and also not require me to lower my standards or involve a whole other robot or machine in it was just using this one. And so for me to just use more force, I was able to get the Jeep up and over the box, and I found a solution to my problem. So whenever you're faced with a problem, the best advice I can give is look at possible solutions and see which one would be best in that situation. I know that every situation is different, and sometimes it's easy solution and sometimes it's tricky, but I guarantee if you work at it, you'll be glad that you put the effort into solving the problem. I hope this helps, and I look forward to hearing about all the solutions you come up with.